Good morning students, welcome to my YouTube channel The Tactical Online Academy. This video is for the students who are preparing for the MBBS entrance examination. Today once again I will continue to explain you the vectors and scalars chapter, and today I am going to teach you about the difference of two vectors. I want to request all the students, please subscribe the channel and like the videos and share it through your social media, and I will be providing you PDF of your courses freely after subscribing and promoting the channel. Thank you. Let's start to study difference of two vectors, that is A vectors and B vectors. First of all, let's understand this geometrically. Suppose we have two vectors here. Let's see geometrically. Suppose here we have two vectors and one vector is A vector. This is A vector, and you know vector has both magnitude and direction. So this is A vector. Then here another vector is B vector, and A vector and B vector are combined at angle theta. Now, first of all, you have to know the negative of B vector is exactly in the opposite direction. So let's draw here dotted line in the opposite direction, and if exactly it is in the opposite direction, then it is minus B vector. So minus B vector is exactly in the opposite direction of the B vector. So here is A vector, and here is in the dotted line, along this dotted line here is minus B vector. So A vector minus B vector will be exactly in this plane. So here is A vector minus B vector is in this plane, in this side. And similarly we can draw dotted line along this direction, and it is in the opposite direction of A vector. So here this one is minus A vector. So B vector minus A vector will be exactly in this plane. So here is B vector minus A vector. So here is B vectors and minus B vector is exactly along the opposite direction of B vector. So it is minus B vector, and so A vector minus B vector is in this plane, and B vector minus A vector is in this plane. And if you have to calculate minus A vector minus B vector, it is exactly in this plane. Here is minus A vector minus B vector. So it is the geometrical detail of difference of A vector and B vector. I want to show you separately once again. Suppose here is A vector and here is B vector, and suppose A vector and B vector are combined at angle theta, then minus B vector is in this direction. So here is minus B vector. So A vector minus B vector is exactly in this plane. Here is A vector minus B vector, because A vector is here and minus B vector is here, and here along this line A vector minus B vector is there, and here A vector minus B vector is also obtained by the parallelogram law of vector, which I have already explained to you. So it is the meaning of A vector minus B vector. Now let's see another B vector minus A vector separately. Suppose here is A vector and here is B vector, and A vector and B vector are combined at angle theta, then minus A vector can be drawn in this direction. Here is minus A vector, and you know minus A vector is exactly in the opposite direction of A vector, and B vector minus A vector will be exactly in this plane. Here is B vector minus A vector, and B vector minus A vector is also obtained by the parallelogram law of vector. So it is B vector minus A vector in this plane. Then after, let's see minus A vector minus B vector, and suppose here is A vector, suppose, and here is B vector, and A vector and B vector are combined at angle theta. Then along this plane we can draw bold line here. Here is minus a vector. It is opposite to a vector, then minus a vector, and exactly opposite of b vector is minus b vector. And exactly in this plane here we can calculate minus a vector minus b vector, and minus a vector minus b vector is also calculated by the parallelogram law of vector. Now you have to know that a vector minus b vector and b vector minus a vector are different. Like a vector minus b vector is not equal to b vector minus a vector, because in the diagram you have seen, if here is a vector and if here is b vector, if here is a vector and here is b vector, then you know a vector minus b vector is in this plane. Here is a vector minus b vector is in this plane, and b vector minus a vector is in different plane, b vector minus a vector. So a vector minus b vector and b vector minus a vector are not equal. So it is different. It is clear from the figure. A vector minus b vector is not equal to b vector minus a vector, but their magnitude is equal. Like magnitude of a vector minus b vector equals to magnitude of b vector minus a vector. Yes, although we have a vector minus b vector not equals to b vector minus a vector. So difference of two vectors are not same. Like a vector minus b vector and b vector minus a vector are not same, but their magnitudes are equal. This also you can understand from the formula of the magnitude. So let's see the formula of the magnitude. First of all, formula of magnitude of a vector minus b vector. It is obtained by parallelogram law of vector, that is root under a square minus 2ab cos theta plus b square. So it is the formula of a vector minus b vector magnitude. Modulus of a vector minus b vector is obtained by this formula, and formula of modulus of b vector minus a vector or magnitude of b vector minus a vector is also same. It is also obtained by a square minus 2ab cos theta plus b square. So both are obtained by same formula. So magnitude of a vector minus b vector and magnitude of a vector minus b vector are equal. Magnitude of a vector minus b vector equals to magnitude of b vector minus a vector. So it is equal. So it is clear from this formula. So magnitude of a vector minus b vector is calculated by this first formula, and magnitude of b vector minus a vector is calculated by using this second formula. Then let's see the direction of a vector minus b vector. Direction, we have already seen magnitude. Now direction of a vector minus b vector, and direction is obtained like this. See, uh, direction is obtained by suppose angle angle between angle between a vector minus b vector and a vector is alpha. Suppose angle between a vector minus b vector and a vector is alpha. Let's see in the figure what I mean to say. Suppose here we have a vector, then we have here b vector, then you know minus b vector is exactly in this direction. Here is minus b vector, and here in this plane a vector minus b vector. Okay, and it is obtained by parallelogram law of vector. And suppose angle between this a vector minus b vector and a vector is alpha. This angle is alpha. Suppose a vector minus b vector makes angle alpha with a vector, then alpha is obtained by this formula. That is the direction of a vector minus b vector. Alpha equals to, it is tan inverse b sine theta upon a minus b cos theta. And you know theta is angle between a vector and b vector. So this is the direction of a vector minus b vector. Okay, this is direction of a vector minus b vector is obtained by this angle alpha, and this angle alpha is with a vector. So this is the formula to calculate angle direction of a vector minus b vector. So now let's see the direction of b vector minus a vector. Suppose we have b vector minus a vector, then suppose b vector minus a vector, the figure is like this. Suppose here is a vector and here is b vector, then you know in opposite of a vector here is minus a vector, and here in this plane we have b vector minus a vector. And suppose this b vector minus a vector makes angle alpha with b vector, suppose like this. Then here if b vector minus a vector makes angle alpha with a vector, like b vector minus a vector, and it makes angle alpha with b vector as I have shown you in the figure. Then formula of alpha will be tan inverse a sine theta upon b minus a cos theta. A sine theta upon b minus a cos theta. Okay, this is the formula of direction of b vector minus a vector. And you have to know this fact that now angle between a vector minus b vector. See here, angle between a vector minus b vector and b vector minus a vector is always exactly 180 degree. This you can understand from the figure. Angle between a vector minus b vector and b vector minus a vector is 180 degree. You can understand from the figure. See here. Why it is 180 degree? Suppose here we have a vector in this direction and we have b vector in this direction. Then angle between a vector and b vector is theta, suppose. Now exactly opposite of a vector, here we can draw minus a vector, and in the opposite of b vector here we can draw minus b vector. And you know a vector minus b vector is exactly in this plane, a vector minus b vector in this line, and b vector minus a vector is in this line, b vector minus a vector is in this line, and angle between b vector minus a vector and a vector minus b vector, this angle is exactly 180 degrees. So from this figure you have to know angle between a vector minus b vector and b vector minus a vector is exactly 180 degree. Then you have to know some other facts. Let's see some special case. Special case number 1. So we know the formula of magnitude of a vector minus b vector is root under a square minus 2ab cos theta plus b square. This is the formula of magnitude of a vector minus b vector. Now if theta equals to 0 degree, suppose, then you know magnitude of a vector minus b vector is exactly obtained to be either a minus b or b minus a, either a minus b or b minus a, because you know cos theta equals to, here cos theta will be cos 0 degree and cos 0 degree equals to 1, so it will be a square minus 2ab plus b square, and root under a square minus 2ab plus b square will be either a minus b or b minus a, and it is the minimum value. So value of a vector minus b vector is minimum when angle between those two vectors, a vectors and b vector, is 0 degree. This is the fact you have to know. And let's see another special case. If angle between a vector and b vector theta equals to 180 degree, then you know cos theta equals to, it will be cos 180 degree and it will be minus 1. And in this case magnitude of a vector minus b vector equals to, you know the formula, root under a square minus 2ab cos theta plus b square. Then you know cos theta part is minus 1, then it will be a square plus 2ab plus b square. This part will be a square plus 2ab plus b square, so it will be a plus b, and this a plus b is the maximum value. This one is maximum value of magnitude of a vector minus b vector. So you have to know this fact: the value of magnitude of a vector minus b vector is maximum when angle between a vector and b vector is exactly 180 degree. So this is the special case you have to know. This is the second special case. Now let's see third special case. When theta equals to 90 degree, suppose theta equals to 90 degree, then you know cos theta equals to, it is cos 90 degree, and cos 90 degree equals to 0. Then you know the formula of a vector minus b vector, modulus equals to, same formula that we have to use here, a square minus 2ab cos theta plus b square, and you know this part will be 0. Then we obtain a vector minus b vector magnitude equals to root under a square plus b square. So magnitude of a vector minus b vector is root under a square plus b square when theta equals to 90 degree. That means angle between a vector and b vector is 90 degree. This is the special case you have to know. In this way you have come to know the maximum value of a vector minus b vector magnitude is maximum value a minus b, and okay, sorry, a plus b, and minimum value is a minus b. So the limit of magnitude of a vector minus b vector is, it is like this: a minus b is less or equals to magnitude of a vector minus b vector is less or equals to a plus b. That means the value of a minus b, value of a vector minus b vector, that is magnitude of a vector minus b vector, is maximum a minus b, and so a plus b, and minimum a minus b, and it is a maximum when angle is 180 degree between two vectors, and the value is minimum when angle is 0 degree between those two vectors. So this is the limit of a vectors minus b vector. Then you have to know some other special case, like if those two vectors, magnitude of a vectors and magnitude of b vectors are equal. Suppose their magnitudes are equal, and that is equals to a, then in such case the magnitude of a vector minus b vector is found to be 2a sine theta by 2. So it is the important question for your entrance examination. If magnitude of a vector and magnitude of b vector is equals to a, then magnitude of a vector minus b vector is 2a sine theta by 2. Exactly, this is obtained. And another special case you have to know: if there we have magnitude of a vector minus b vector, magnitude of, it is like this: magnitude of a vector equals to magnitude of b vector equals to magnitude of a vector minus b vector. Then in such case the angle between a vector and b vector theta equals to exactly obtained to be 60 degree. So this is the detail of the difference of two vectors, a vectors and b vectors, that I have explained today. And I'll be coming with more lessons of the vectors and scalars chapter in the upcoming videos. For today, thank you and goodbye.